Welcome to the Organic Chemistry Podcast, Dr. Brian Lloyd's Scribblecast of organic chemistry lectures and solutions to homework problems. In today's homework solution problem, we are looking at problems of chirality, specifically solving and drawing and also naming chiral molecules that have one chiral center. Now, in this question, we were asked to just determine whether the molecule is R or S and to show our work. In order to make it easier, we were asked to draw the longest carbon chain vertical and highest priority group of that carbon chain at the top. Now, in this scenario, it is a bit ambiguous as to what is the longest carbon chain. We have 1, 2, 3, we have 1, 2, 3, so there are several possibilities, 1, 2, 3, and if you choose a different 3-carbon chain as your longest carbon chain, that's okay. As to the group that is highest priority, you actually have to go back to your chart of general IUPAC nomenclature. And if you look at your chart, you'll notice that C triple bond N is nowhere to be seen on that chart. You have to go to the chart below it, the one you weren't required to memorize, and in that case, you'll find that C triple bond N is higher priority than the aldehyde. Now, since in the following question I told you to put the chlorine, I believe, to the top, some of you may have chosen to put CH2Cl on the bottom. I will accept that. We'll do this. CH2Cl on the bottom. However, if you put the aldehyde on the bottom, that's fine. But the highest priority group by nomenclature is the cyano or nitrile group. And so now what we have to do is look at a 3D structure and say, okay, if these two are going away into the void, where do the other groups go up? Now you can take a model out, assign different colors to all of these 4 groups, and then orientate the C triple bond N and CH2Cl so they're going into the board. If you do that with your model, what group ends up on the left? Well, if you said chlorine, you're right. So for this 3D structure, chlorine would be here and aldehyde. I'm going to write the aldehyde as CHO. So now we have to determine RS. We only need to prioritize. And the highest priority group, of course, chlorine, carbon, carbon, carbon. Chlorine's higher atomic number, so chlorine's 1. Now, when you have carbons, identical groups, rule number 3 of EZ prioritization rules states that you proceed out the chain to the first point of difference. And you go out to the highest atomic number. This carbon's highest group off of it is a chlorine. This carbon has an oxygen, this carbon has a nitrogen. Carbon with the chlorine is higher atomic number than oxygen and nitrogen, so he's 2. Carbon with oxygen is higher atomic number than carbon with nitrogen, so he's 3. And so lo and behold, the group we put at the top by EZ prioritization is the lowest. Now, when I say in the question highest priority group of that chain, I'm talking by regular nomenclature, not EZ prioritization. Now, in order to solve our RS, we have to do one interchange, okay, and we have to get this guy, one interchange. Probably won't fit that on the screen. I'm going to say one interchain. That should be change, but I've run off the screen. One interchange. And I'm going to switch number 4 with number 2. So I will now draw this. And CH2Cl ends up at the top. I still have my CHO, my aldehyde group to the right, my Cl to the left, and C triple bond N is now at the bottom. That gives me 1, 2, 3, and then number 4 is here. And now I draw a curve from 1 to 2 to 3. If I draw a curve from 1 to 2 to 3, what is that? That is R, because it's clockwise. So what is the original? Well, I did one interchange, therefore that's an odd number of interchanges, so it's the enantiomer, so it's S. Hence, this molecule is S. Now, if you drew a slightly different fissure in this case, and you actually put the aldehyde at the bottom, that's okay too. That would have satisfied this question's constraint of longest carbon chain vertical. Excellent. Well, why don't we continue with this question now and try the next problem. So we'll just erase this if we can and get it erased as quickly as we can. See if I can make one interchange fit on the screen this time. Excellent. And what we're going to do now is we're going to change these groups around our chiral carbon to the next question. Okay, on the right I have a CH double bond and an F2C, F2 and a C. And then I have an aromatic ring, and just in case, because this video does get shrunk down to fit the iPod, I'll put dots for the carbons so you can tell it's a six-membered ring. Okay, at the top I have a CH2, and then another CH2, a CH, off the top of that is a CH3, and then there is a CH2, CH3. And off at the bottom we have a CH2, a CH2, a CH2, and a Cl. Okay, now hopefully I get this right. If I don't get it correct from what you were given in class, just note you could do what I said to do in class. I believe I told you in this case when you do the longest carbon chain in the fissure you were to put the chloral group to the top. I may have said to the bottom, and if that's the case, let's do it both ways. Actually, that might be useful. Let's start by putting this group to the top, the chloral group to the top, and see what actually we get. So, if I do that, and I put the chloral group to the top and solve this question, I get CH2, 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 Cl. Okay. Now, if I have the other group at the bottom, that's a CH2, CH2, CH, CH3, and then there's a CH2 and the CH3. Okay. Now, if I draw this orientation so that, remembering in a fissure the vertical is going away from you, what ends up on the left? Well, what ends up on the left is the aromatic ring. I'm going to just draw it like this. Actually, let's show the bonds because we're going to have to prioritize, and that can be tricky. And then over here we have CH, double bond, Cl. F2. Okay, so what we're going to do now is prioritize around a fissure, and since around the chiral carbon there are 4 carbons, we must use rule 3 and proceed out the chain to the first point of difference. So we're looking at all 4 carbons. This carbon has a carbon attached to it. He has a carbon, he has a carbon, he has a carbon. This guy now has another carbon. He has an H, he has an H, he has another carbon. This carbon has an H, he has a third carbon. They have the other H's. So first point of difference is the aromatic rings number 1 because he had hit 3 carbons. If we do it again, carbon, carbon, carbon. This guy hits an H, he hits an H. This guy hits the second carbon being due to the double bond, so he becomes number 2. So now it comes down to which one is number 4. If I proceed out, carbon, this carbon has a carbon, he has a carbon, he has an H, he has an H, he has an H, he has an H, they're tied, proceed out. So we're now at this carbon. This carbon has a carbon, he has a carbon, he has an H, he has an H, he has an H, he has an H, still tied. Oops, it looks like I misdrew this. I'm sorry. I thought something was up. There should have been another CH2. And then a Cl. Okay, so now we proceed out to the next carbon. So we're now looking at this carbon of the chain. This carbon has a carbon. He has a carbon. This carbon has an H. He has another carbon. We never make it to the chlorine, and this guy becomes number 3. So it turns out now group 4, the lowest priority group, is actually the group long chain with the chlorine. All right. In order to determine the chirality, I'm going to have to draw a fissure where I put group number 4 to the bottom. Now because I can't draw this, all right, I am going to just use the numbers. 1 stays where it is, 2 stays where it is. I'm going to switch 3 and 4. If I draw a curve from 1 to 2 to 3, this guy is S. So the original, because I did an odd number of interchanges, is R. Okay. So this molecule's R. Now just in case I told you to put the CH, the long chain with the chlorine to the bottom, let me just quickly change that molecule. And what we'll do, so we'll put the chlorine to the bottom this time and show you what you would have gotten. If you had drawn the fissure by placing the chlorine chain to the bottom, you would have had this, you would have had a methyl here, a CH2, and that's the CH3. If you had drawn it that way, if you had drawn it that way, where would these end up? Where would the, what group would have ended up on the left in your fissure? And again, you would spot this using a model by assigning colors. The alkene would have ended up on the left, and the aromatic ring would have ended up on the right. And again, if you went through and prioritized, you'd find this carbon of the aromatic ring has one carbon, he has a carbon, he has another carbon, he has another carbon, he has 3 carbons, he has an H, so the aromatic ring gets 1. This guy has 2 carbons attached to him, counted to the double bond, these have 1, so he gets 2. And then if you proceed out the chain, this carbon here has a carbon, he has a carbon, he has an H, he has an H, he has an H, he has an H. Proceed out, look at these 2 carbons now, carbon, carbon, H, 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 still the same. Proceed out, get this carbon now. This carbon has a carbon, he has a carbon, he has another carbon, he has an H, first point of difference, he becomes number 3. If you drew it this way, number 4 ends up on the bottom, so you don't have to do any switches, you just go 1, 2, 3. Draw your curve because number 4 is on the bottom. Again, here's R. So this molecule turns out to be R. So this represents the first homework problem. Hopefully you can take a close look at this. Make sure you understand it. You should be able, with fissures, to show your work when attempting to determine RS nomenclature. And this gave you a little practice doing so. I'm Dr. Brian Lloyd. This is my Scribblecast. Thank you very much.